This is section 7.6, and we're going to look at double angle formulas and half angle formulas. These are not things that you necessarily have to memorize, but you do have to know how to use them. So I would either print this sheet or go to your basic trig identity sheet and note where those are, because we're going to use those in our problems. Let's look at some examples of how we would be doing that. So this one says find sine 2 theta, cosine 2 theta, sine of theta over 2, and cosine of theta over 2. So we're using double angle and half angle given just one set of information. So we're given that sine theta equals 3/5. That's an equals. I don't know why that's not working. And that theta is between 0 and pi over 2. So that tells me it's in the first quadrant. So you want to draw that triangle, come out from the origin, drop a perpendicular. And if sine is 3/5, that means your 3 is here, your 5 is here. You want to figure out this number. It's pretty easy when you have a 3 and a 5, because a 3, 4, 5 is a special right triangle. But if you don't have that, you're going to say x squared plus 3 squared equals 5 squared. And you come up with x is 4. So if that's 4, then cosine theta is 4/5. So I highlighted those two because we're going to need those probably in all of our formulas. So to find sine 2 theta, here's the formula: 2 sine theta cosine theta. I'm just plugging in 2 times 3/5 times 4/5. I'm going to multiply across the top and get 24. I'm going to multiply these two denominators. That's 25. There's my final answer. Cosine 2 theta. Now there are a couple of formulas. Let's go back up here for a second. So cosine 2 theta, all three of these work, and you could choose any of them depending on what you're given. That could affect which one you want to use. I chose to use this one because I do have both cosine and sine. So cosine squared theta minus sine squared theta. Plug in your 4/5, your 3/5, you get 16 over 25 minus 9 over 25, so we got 7 over 25. Those are fairly easy. Sine of theta over 2. It's plus or minus the square root of 1 minus cosine theta over 2. Well, you're going to choose the positive one because you know you're in the first quadrant and everything's positive there. So I'm going to use a positive value out here. So it's 1 minus 4/5, because I'm plugging in cosine, over 2. The rest of this is algebraic. You're going to make this 1 minus 4/5 is 1/5, because that's 5/5. So I have 1/5 over 2. Then I make that 1 over 10. And I can break that into two radicals, square root of 1 over the square root of 10. Well, the square root of 1 is 1, so I have 1 over the square root of 10. When you rationalize that, you get square root of 10 over 10, and you want to do that for your final answers. Cosine of theta over 2, same idea. We're going to use the positive, and it's 1. The only thing different, this was 1 minus cosine. This is 1 plus cosine. So now I have 9/5 over 2, which is 9 over 10. Square root of 9 is 3, so I have 3 over the square root of 10. I rationalize it, and I end up with 3 square roots of 10 over 10. So that was doing all four, given this one bit of information. All right, let's look here. Use the half angle to solve this. It says find sine of 22.5 degrees. Well, we don't know that. We could do it on the calculator, but we can't do that algebraically. But if we use the half angle says sine of theta over 2 is equal to this formula. And so if we double this, it's 45. And we do know information about 45. So the formula is plus or minus square root of 1 minus cosine of 45. Cosine of 45 is square root of 2 over 2. So I have 1 minus that over 2. I have to make that a 2 if I'm going to combine these. So I have 2 minus the square, if I'm trying to make this top one fraction. So I have 2 minus the square root of 2 over 2, and then over 2. So when you end up with this, if you have a denominator and another denominator, that can become one denominator. So we have square root of 2 minus the square root of 2 over 4. Now let's break that into this radical and this radical. And so if you have the square root of 2 minus the square root of 2 over the square root of 4, which is plain 2. So that would be the final answer there. All right, same thing for this one. Let's move this over a little bit. So cosine of 165. We don't know anything about 165, but if we double that, we get 330. And so we do know information about 330. Its reference angle is 30 degrees. 165 is in the second quadrant, so cosine is negative there. We have to remember that. All right, so cosine theta over 2, here's our formula, 1 plus square root of 3 over 2 over 2, because this is, let's look back at the formula for cosine of, I have to go back up. Cosine of theta over alpha over 2 plus or minus 1 plus cosine alpha over 2. So 1 plus, and the cosine of 330 is square root of 3 over 2, all over 2. So then I make this one fraction. That becomes 2 plus the square root of 3 over 2. There's my 1, all over 2. And then we've got two denominators. That can become a 4 on the bottom. The 4, if we make this a radical on top, and the square root of 4 is 2, so there's my final answer. You'll have a lot of radicals in your answers. All right, so that's a brief overview of using the double angle and the half. Let's go look at the problem. So we're looking for tan 2 theta, and there it is right there. We go back to our problem set. That is true. That is the formula. About number 2, sine 2 theta has two equivalent forms, either this or this. Well, if we go back, we look at our notes, sine 2 theta has one form, not two. So that one would be a false. The expression that completes the half angle formula for cosine functions is cosine of alpha over 2 equals. And so you just want to verify that looking at your, so we have cosine theta over 2 right here. And we'll go back, and it is this one. All right, now we get a problem. If sine theta is equal to 2/5 and theta is between 0 and pi over 2, find the exact value. This is like we did in our example. So we know we're in the first quadrant, so we draw it. We go out from the origin, drop a perpendicular. Sine is 2 over 5. We've got to find this number. It was pretty easy in the example, but we do have to use Pythagorean theory here and do this. 2 squared plus x squared equals 5 squared. So that's 4 plus x squared equals 25. X squared is 21. X is the square root of 21. So I put that there. Now I know what my cosine is. It's the square root of 21 over 5. So I probably should have written that over here. All right, so I've added that there, and I have what sine and cosine are, so I can have them to reference. So sine 2 theta, that's our first one. We just fill in the sine and the cosine, 2/5 square root of 21 over 5. Remember, you're multiplying across the top, those three. This is 2 over 1, and then 5 times 5. So we have 4 square roots of 21 over 25. That's what goes in that box. Cosine 2 theta, I used this formula, so I'm going to square both of these. When you square a square root, you just get that number. So I have 21 over 25 minus 4 over 25. I do that subtraction, I end up with 17 over 25. Sine theta over 2, here is the formula. We're going to use the plus one because we're in the first quadrant. 1 minus the square root of 21 over 5 over 2. So I need to make this one single fraction. So that becomes 5 minus the square root of 21 over 5 all over 2. You have double denominator, so that can just become 10 on the bottom. And that would be our answer for that one. Cosine theta over 2, same idea. Instead of subtracting, we are adding. So we ended up with that. Okay? All right. If tan theta is 5 over 4 and theta falls between pi and 3 pi over 2. So we've got tan and we're in a different quadrant. We are in the third quadrant. So we draw it, come out from the origin, drop our perpendicular to the x-axis, and we're back here. Now, we are given that tan is 5 over 4. Tan is opposite over adjacent. But what we need to note is this is a negative x, this is a negative y. That still gives us a positive tan, but we have to use these negatives here. You mess it up if you don't. We figure out what the hypotenuse is by doing our Pythagorean theorem, and we end up with square root of 41. So now I can write sine theta is negative 5 over the square root of 41. Cosine theta is negative 4 over the square root of 41. All right. So I got to do the same for sine 2 theta. I'm going to plug them in. I end up with 40 over 41. And this was, what did I have there? So that just didn't look quite right. That 41 made right. When you square that, you get 16 over 41. You get 25 over 41. When you subtract, you get negative 9 over 41. So that is the cosine 2 theta. The sine of theta over 2, there's my formula. And I'm going to put in the cosine, which we said up here, cosine was negative 4 over square root of 41. In the formula, it's minus here. So that's going to end up being a plus. We have square root of 41, because that's what's on the denominator, plus 4 over the square root of 41, all over 2. Come down here. Oops, let me go back. Get it right in the middle. And so this is what we've got. We got a double denominator, so that can be combined there. And we have 2 square roots of 41 there. We have to rationalize and get this square root of 41 gone. So we'll multiply by that over itself. And in that one, when we distribute over here, square root of 41 times square root of 41, there's a 41, plus 4 of those, over 2, that becomes 41. So now we have the square root of 41 plus 4 square roots of 41 all over 82. That should be our final. And then we need to do the same thing with cosine theta over 2. And let's get back completely over here. And we do all of the same thing, but since we're in the third quadrant, cosine is negative, so we do have the negative out here. We were in the sine, let's see, quadrant 3, yes. So since it's theta over 2 and theta is between pi and 3 pi over 2, but when you take theta over 2, you're going to put it back up here. Well, sine was still positive here, but cosine is negative. So it's really not about that it's quadrant 3, but you're pushed back up to quadrant 2. All right, number 6. Use the half angles to find the exact. So we're trying to find sine of 15. So if we're doing sine of 15, that's the same as 30 over 2. So we're going to do cosine of 30, which is square root of 3 over 2. And so that becomes 2 minus the square root of 3 over 2, and then over 2. So we have over 4. And we ultimately, the square root of 4 is 2. So we look like this. Let's see. So the final answer goes here, and you're choosing G, and you put 1 minus cosine, and you put the 30 degrees in here, but your final answer goes here. 7, we're doing sine of 22.5. I think we did that one maybe in our notes, but 22.5 doubled is 45, so you're plugging in the square root of 2 over 2. We did do that one. We did this exact one in our notes, so you can look back for that one. All right, now this is a little different because we are in radians. All right, so it says find the exact value of tan pi over 8. Well, if we double that, we get pi over 4. So that's the angle that we're going to use. So down here, we would choose, this looks like the formula, 1 minus cosine theta over sine theta. And then we're doing the cosine of pi over 4. All right, because we're choosing to let pi over 4 be our angle that we're dividing by 2. So we've got this. The cosine of pi over 4 is square root of 2 over 2. So we've got, and the sine of pi over 4. So we've got that. On the top, we make that 2 minus the square root of 2 over 2. That's that part, over the square root of 2 over 2. So now we've got a complex fraction. We're going to take this one and multiply by the flip of this one. Those 2's cancel out. So now we have 2 minus the square root of 2 over the square root of 2. We need to rationalize to get rid of that. So we multiply square root of 2 over square root of 2. Then we have 2 square roots of 2 minus 2, because that becomes 2, over 2. If I divide 2 everywhere, 2 into 2 is 1, so I just have square root of 2. 2 into 2 is 1, and I have a minus 1. That is your final answer. So pi over 4 goes in this blank here, and your final answer, square root of 2 minus 1, goes here. And I think that will get you going. We have about 8 questions. Some of them are fairly long, so that will get you through the double and half angle.